have a homework posted for GNU Plot. That will be due next Wednesday.
What about the homework that was due like yesterday or something that was empty?
That got moved. That was the homework. I think it was homework 5's just placeholder, and so that's been moved to next Wednesday. I just have all of those things loaded into Blackboard, and then when they get due, or when they're going to be due, I move the due date around. All right, so I'm going to start talking about data processing at the command line. We've already done some, we basically did some command line utilities to, remove multiple files at once, go around in the file system, create files, edit files. Now I want to focus on if we have some data in files or some text in files, how we can manipulate that data, process that data. Like for example, if we have experimental data that we want to sort through and find the maximum value that was recorded or the minimum value or the average, right? So I want to look at the tools that allow us to do a lot of data processing at the command line. All right, so the Unix philosophy, there's multiple ways of stating this, but sometimes you'll hear, like if you're reading forums about, like you're trying to figure out how to use some bash command, somebody will bring up the Unix philosophy, and that basically says that a program should do one thing and do it well, which means that if you have a program that does something very well, like grep, for example, searches through text and does it very well, and you decide, it'd be really nice if grep could search through text and then sort all of the matches alphabetically. Rather than adding that capability to grep, you should write another tool that does the sorting for you, and then you can use those tools together. So that's basically the Unix philosophy. And so what you'll find is that there's a lot of utilities that, I guess I wrote a cliffhanger here. Apparently, apparently got distracted before I finished this complete thought. Is there even a subject in that sentence, Derek?
Yeah, that's fair.
Okay.
Yeah.
That do various text processing tasks, and you can use these together with pipes. So pipes are, and this is definitely not an overstatement, they're probably the most powerful feature of the command line. And I haven't even showed them yet because there's so much more. I mean, there's all the stuff that you need to know how to do at the command line before using pipes makes sense. So when a command prints something to the screen, like when you type ls, right, it gives you a list of all the files in the current directory. What it's actually doing is it's printing to standard output. And when a command reads input from the keyboard, like we open up GNU Plot and GNU Plot starts reading commands from the keyboard, what it's actually doing is reading from standard input. And what a pipe does is send the standard output of one command to the standard input of another command, which means that you can take commands that are completely unrelated from each other and link them together. So anything that prints something to the screen can be sent to another command for further processing. And that's what the pipe is. And a pipe is a vertical bar. So we do, when we do pipelines or we use the pipes, we have a command here, a vertical bar, the next command. Now, most of the commands that we've already used, like head, cats, tail, they actually take input from either standard output, or excuse me, standard input or files. So for example, if you run head and you give it a file name, it'll print out the first 10 lines of that file, right? Well, you can also give it standard input and it will print out the first lines of standard input, which means that you can send the standard output of one command to head and get head to process that input.
So if you had like two different programs that you had made that you wanted to pass an argument from one to the other.
Yeah, if you wanted to pass data between a couple of programs that you wrote, all you have to do is read and write from standard input and to standard output, and you'll be able to link those together. Yeah. So let's look at an example. The example I have in the slide is if I type ls and then pipe that to head. If I do ls cat, you can see that I get several entries here. And if I pipe that to head, I only get the first 10 entries. We've seen this before. Like if I type head without a file argument, it basically, it looks like the command is hung, right? It doesn't return. But actually, if I start entering stuff, what does it do? It prints out everything I enter until I get to the 10th entry, and then it quits. That's because it's waiting for 10 lines of standard input that it can output to the screen before it quits. If I run head with the tack in 3 option, well, then I would expect this to exit sooner, and it does. So head can read from standard input, and then it will output the first 10 lines without any options, or you could give it an option to output the first 3 lines. So all of those commands that we've used so far, they do this type of thing. Head, tail, cat, word count, they all take standard input as a source of data that you can then send the output of one command to the input of those commands. So that's going to be very powerful. So there's a lot of useful commands for doing data processing, and the theme that you find with all of these commands is that they basically just do one thing. There's no reason for them to do more than one thing because you can always connect them with pipes. And so some of the useful commands that we'll discuss, bless you, this period, bless you again, during this module, some of them we've already seen. grep is going to search input. grep will search through files if you give it file names as arguments, or it'll search through the standard input if it's not given any arguments, which means that you can pipe something to grep and extract lines that match a given text. Head prints the top of input, tail prints the bottom of input. Word count counts the lines, characters, and words in the input. Sort, which we haven't used before, will sort input. You can sort input alphabetically or numerically. The column command is very useful if you're dealing with data that is in columns, like if you've got a table of data that you're trying to manipulate, the column command will align the tables so that they are all left aligned, for example. It makes it easy to see the columns when you're working at the command line. The cut command allows you to pull out columns from input. So let's say you've got a GNU plot file. It's got 4 columns of data in it, and you want to extract the second column so that you can take the average of the second column or something like that, right? Or you want to see what the maximum of the second column is. You can use cuts to get that second column by itself and then send that to another command to count the number of characters or to average them, something like that. Sequence is a nice little utility command that will just print out a sequence of numbers. Sometimes you want to generate a list of numbers 1 through 10 so that you can start some pipeline. Sequence command will do that. Paste will put 2 inputs together side by side. So if you've got 2 files that have the same number of lines and you want those to be combined into a single file where you have 2 columns, you can use the paste command to do that.
Well,
and then
they have just separate number of lines.
What's that?
But they have different numbers.
I believe that they will be put next to each other, and then the one that's longer will then be on its own. Will be all the way on the left on its own lines.
Okay.
I believe. We can look at that. And then BC is a command line calculator. So if you want to do some quick calculations at the command line, you can use the BC command. All right, so let's get started. Let's just look at how pipes work and then some of the commands that are useful and how they work together. I'm going to try to go slower than I normally do so that you have an opportunity to test this stuff. I have a sandbox posted online. I'm sure you already have that downloaded and unpacked. Of course. Download, open, that's nice. That could easily be achieved. Maybe that'll be the final.
Okay.
On laptop lid, open event, download and untar the sandbox. All right, so I'm in the sandbox directory. Remember the find command. If you don't give it anything except a directory, it basically finds all files and directories. Okay, so this is a list of all the files in the sandbox directory and directories in the sandbox directory. Now, one of the examples that we did was, let's say that you wanted to look for files that had a path that matched a pattern. So if you could get a list of all of the file names and then use grep to search through those file names, you could get a list of files that matched a given pattern. And the way that we did this in the previous module was to first create the file name list, send that output to a file, and then use grep to look at that file and match patterns. So let me do that. I'm going to find all files in this sandbox. I'm going to send that to a files.txt file. And then I'm going to run grep, and I'm going to look for all paths that include temp slash. So this would be things that are in a directory that ends with temp, which should include all directories that are named temp, but would also include directories that were, you know, file.temp or data.temp. And if I do that, I get this, right? So I get a listing of directories. These are just lines in the files.txt file that I just created that match that pattern. So I've got some of them that are in a temp directory that's in the current directory, and then there's apparently a temp directory inside the code directory, so I have some matches there. All right, what pipes allow us to do is completely skip this piece where I have to create a file that contains the stuff I want to search, and instead just pipe that straight to grep. So I'm going to remove that temporary file, files.txt. I'm going to run the find command, and then I'm going to do a vertical bar. That's the pipe. And so everything that the find command outputs is going to be sent to the grep command. And the grep command takes an argument, which is the pattern that I want to find. And so it's going to search through all the lines that the find command produces and only print out the ones that match. So this is the same output that we saw before, except I didn't have to create a temporary file to do it. It's like magic, isn't it? That's what I thought when I found it, except I was being serious. I was like, you've got to be kidding me. This is amazing. It's like, I don't have to write a program to do everything that I want to do. I just take this collection of things. What's that? What's going on, Patrick? Standing by.
Oh, what is the directory that you're currently in?
I'm in the base, like the top of the sandbox directory.
Yeah, mine doesn't output anything.
Just find output anything?
Yeah, mine outputs
There we go.
anything.
Does it contain things that say temp in it? Standing by. Does it work now?
Yeah.
What was going on?
I was putting it into a file and then trying to grab it.
Ah,
I tried to reuse
Why do you say
commands.
the standing by?
oh, no reason. It's actually a joke that I have with some old work colleagues. We'd be in the computer lab. It's like, hey, what's this? Like, stand by, which means give me a second, man. Get off my back. And then the appropriate response to stand by is standing by. All right, so let's say that we know that there are files that contain the word error in them because some stuff, I don't know, whatever the reason is, we've got programs that we know we're processing data, and if something went wrong, they print an error to the file. So if I run grep error star, that's going to try to run grep on all the stuff that's only in this current directory, which isn't actually what I want, because I want to see if there's any files anywhere in the sandbox that contain this string error. And then I also get these, I get grep complaining because star expands to things that are files and directories, and grep is not going to run on a directory. It will only look for content and files. So that's not actually what I want to do. Instead, I could create a list of all files, and I'm going to get rid of directories by using the tac type option to find. So here I'm using a command substitution example that we did in the previous module. This command here, find./tac_typef, is going to print a list of all regular files that are in the sandbox directory. I'm going to take that and insert it into the command line as if I typed it out manually, and I'm going to generate a list of files for grep to look at then. So now I get a list of all files that contain the word error in caps. A lot of these are the same. So in the simulations directory, apparently there were several files that there was an error during the processing. Some of the files didn't contain data, but then there's some other ones up here. So I've got some bad data file or some bad data errors. I've got no data, divide by 0. These are just various errors that were apparently ran into while some program was trying to process data. let's say that I wanted these lines. So I wanted the error lines, but I only wanted to see the error lines that were due to bad data. So now I have a list of lines. Of these lines, I really only want to see the ones that say bad data. So all I have to do is send the output of grep to grep. So I'm just search for error, and then I search for bad data. So let's rerun the grep command. But instead of just letting it print its output to the screen, I'm going to run that through grep again, and I'm going to look for bad data. So now I have a list of all of the files that contained errors that were caused by bad data, right? Whatever that error is. Presumably, if I wrote the thing that's doing the processing, I would know what that error is. Yes, Tyler? Got a lot of those today. All right, the next thing I'm gonna, you know what, never mind. I'm not gonna tell you anything. You know, sometimes when we answer our own questions, other people benefit from, except for Patrick's problem, that was clearly.
Oh no, mine was the same. I was gonna say, what happens if we were in cat, or find something, and we give that to a cat command, and then grep that, and I realize that that would be completely redundant.
Oh yeah, the cat command just takes lines and prints them to outputs. So yeah, in that case, but it would still work. It would just be an extra command. All right, I'm going to look for files that contain error, and then I'm going to just pull out the ones that say bad data, and then I'm going to count how many of those errors there are. Now here I could just look at them, right? And if I, you know, Derek would probably somehow get these to show up in his file manager that he would then go through and count them one by one. But if I've got thousands of these files, then, you know, that's not going to work. So I can run the output through WC, which will then count number of lines, words, and characters. And if you remember, the TACL option to WC says just print out the number of lines in the input. So this is a way for me to count how many errors were caused by this bad data problem. And so here I've got 3 commands, pipes together. You can do this indefinitely. Just keep tacking on pipes. And you know, I will typically refer to this as a pipeline. You're creating a pipeline where data is thought to go through the pipeline like a stream, and that's exactly what these commands are doing. They're editing or manipulating the stream. Data comes in, goes through one command, comes out the other end, and you're just connecting them with pipes. You're creating a pipeline to do the data processing. Yes, Tyler.
So you could do like BC, that portion, and then divide it by another, by like all of the files there. So you can say how many of these have bad data, or have error content data. Possible. Yeah, so you would.
Oh, what percentage of
Yeah,
files?
What percentage of files have errors caused by bad data?
Yeah, you could do that. So you could count the number of files like this. Then you could do it without the second filter, get the number of total files, and then you could use BC to calculate that ratio. Yeah, that's right. All right, so let's look at some of these new commands. All right, I'm back in the top directory of the sandbox. There's a directory called students. I'm gonna go in there. This directory contains a file called info.txt, which just has information on students that have taken this class in the past, social security number, age, Tiger ID, rank in the class. After you guys are done, you'll go into the database.
Vogel McLovin.
We've had some characters. We've had some characters take this class.
George Costanza.
Yeah, he was. He got angry a lot.
Yeah. You even had Agent Smith.
Yeah, there's been a lot of people that have been interested in this class. Yeah. All right. Now we know what the head command does. Prints out the first 10 lines. It looks like I've got 12 lines in here. Okay, so the first 10 lines. Starts with that header, which tells you what each column is, and ends with Arcot Ramathon. Ramy, yeah, he was a good one. He was always running the repeater and stuff like that. Head takes options. Head does one thing. It prints the top of input. It takes options that sort of adjust how it's going to do that. But basically, every version of head that we run does the same thing. Prints the first however many lines we want it. So if I run head tack 5, I get the first 5 lines. So now it ends with McLovin. Cat just takes the output and prints it to standard output. So cat is often, you can use cat at the very beginning of a pipeline just to get the file contents to standard output so that you can then send it into a pipeline. But the nice thing that cat does, the reason that it's called cat is because it stands for concatenate. If you've got more than one file and you want to get the lines of all of those files to standard output, cat will concatenate all of the lines of multiple files. So here's the column command. This is what the column command does that's nice. Now by itself, it doesn't do anything that's very useful. It doesn't really make sense what it's doing here. But if you give it the tac T option, column will automatically determine how many columns are supposed to be in the output, and then it will left align everything. So now you see everything lined up very nicely, very pleasing to the eye. And so we've got first names, last names, social security numbers, ages, Tiger ID, and then rank.
The last digit of the social security number is 4 digits.
Yep, so we only got 10
You
digits.
can
to
guess
find
though. I
first.
mean, come on, there's only 9.
I mean, there are privacy concerns.
Age 66.
He's an old man.
Yep, he was very wise man. Had a lot of wise things to share with the class. Poor Bubbles, man. I think he had a hard time seeing the screen. Is what his problem was. He was always, always acting like he had a hard time seeing. Nick Papagiorgio, lucky son of a gun there.
Yeah, Philip really didn't come back after Christmas break either.
No. All right. The sort command will sort lines in a file, and it does this. Let's see, it does it alphabetically by default. So I'm gonna get lines in this file sorted. So if I sort by first name, I get Arcot listed first, and then the 2 Rusties are listed last. If I wanted to sort on the second column, I can tell sort to do that. Sort takes an option. So sort does one thing and it does it well, but it does various versions of this. So the sort command can take an option tac K, which says sort this on the second column, not the first column. I believe tac K stands for keys. So sort calls these columns keys. The thing that's confusing is that because these programs are written individually, right? They don't all have the same author. Sometimes they have different option names for basically the exact same thing. So sort refers to columns with tac K, cut refers to columns with tac F. But, we just have, when you start using them enough, you know what the options for each command are. So don't expect some uniformity between these commands. So this is now sorted on last name. We got Clark, Costanza, Fry, all the way down to Smith.
And first alphabetically is in the middle of the list instead of being up at the top.
Yeah, exactly. So this
I was gonna say something wrong.
this header line here is getting sorted with the input. Yeah, divides from the top of the class. Oh, look, Bubbles sorts as last alphabetically and by class rank and by grade.
Because it does it alphabetically.
On the last name.
On the last name, yeah. This last one that we just did was on the last name.
Yeah, but on contrary, it would sort that alphabetically, right? So it would go.
Oh, yeah.
11 to 1.
Yeah, it's going to do that, which we could tell. But I'm saying if you actually look at his class rank sorted correctly, we'll see that issue show up. Let's see here. I'm going to sort on fourth column. So what is that? 1, 2, 3. That's age. So I'm going to sort by age. And this isn't actually an issue because all of the ages have 2 characters. So this actually sorts numerically. Sometimes what you're going to find is you want to sort something numerically, but it doesn't sort correctly because sort is going to, by default, use alphabetical, which means that each one of these numbers is actually a character in its alphabet, and it will sort based on that. So I think that I've got an example that illustrates this, but if I needed to fix it here, which I don't, I would sort on the fourth column, and then I would give the tack in option. That says do a numerical sort. This might, I don't know if this is going to change the position of the header or not. It looks like it does. So the header now is listed first, and then I have a numerical sorting of the age. Yeah, a lot of them were. Hey, did you see that Super Trooper 2 is coming out next year?
Yeah.
That's you can say that every year. It's coming out next year, guys. Do you see it's coming out next year? All right, so let's sort on the 6th column, which is class rank, which it has already been pointed out by Tyler, is not going to sort correctly. And so what I see is on class rank, I get 1, 10, and 11 all together. That's because this is being done treating these as characters, text characters instead of numbers.
Use the tack in.
And I use the tack in option to get those to be treated as numbers.
What does it do in case of identical answers? So
Oh, I have no idea. I don't know what its algorithm is. I would assume that it maintains whatever the current order is, but who knows? It might, depending on what algorithm they use, it might be simpler to just let the algorithm do whatever it does. Now, if I want to reverse the order, so let's say that I want to sort it. Let's see. Right now, it's sorted ascending in rank, and I want to do the opposite. I want to do the last rank first. Then the sort command also takes a option tack R, and that just reverses whatever the sort is going to be. So I'm going to sort on the 6th column. I want to do it based on numerical sorting, and I'm going to reverse whatever the order is so that I get the last rank at the top of the list. The sort command takes a file as an argument, but if there aren't any files that are given, it'll take standard input. So you can use the sort command not just at the beginning of a pipeline, but you can put it inside, in the middle of a pipeline. So here I'm going to use cat to get the text to the standard output. I'm going to run that through the sort command, and then I'm going to format it very nicely with the column tack T command. What did I misspelled intro. Info.
That completion, dude. Come on.
That's right. Info.
No.
Type
Do it all on
that.
it.
So.
There it is. Tab complete.
And so look, since you typed that you forgot that it's like
Yeah.
the character before it. It's type like 2 characters, hit tab. Type 2 more characters, hit tab.
Nope, here it goes again. Looks like I did a copy and paste here. That was a menacing laugh. All right, so let's do this. I'm going to sort on the 4th column numerically in reverse. The 4th column is age. I want to get rid of this header line that's been sliding around up and down in here, basically, right? And so the way I'm going to do that is I'm going to remove that before I do the sort. The way that I remove it is I run the file contents through grep first. I tell it to only print lines that don't contain the string SSN, which should be everything except for that header. Run that through sort, and then run that through column to format it. So basically, once you learn about, look into what commands are available, what do those do. A lot of this now turns into just a problem solving exercise. Like, okay, if I want this, like what if I wanted to sort everything without the header, but then I wanted to add the header back? Is there a way that I could construct a pipeline that would do that? So it's just a big problem solving exercise to see if you can get these commands to work together to do something that you want. So right now, I don't have the header file or the header line in there. The cut option or the cut command, which is fairly limited. In this case, it's going to be okay. The cut command takes an option TACF, which is the column number that you want to cut out from the text. And you can give it more than one column if you want. But the cut command is a way to get one column out of a multi-column set of data. And you can see that it actually just prints out everything. That's because by default, the cut command wants tabs to separate the columns. And if you don't have tabs separating the columns, which in this case I don't, I just have spaces, then you need to tell the cut command that spaces are what separate the columns. So I'm going to rerun this, but then I need to give it the TACD option. And I need to tell it to use a space. And the only way to tell it to use a space is to quote a space. So I need to put a quote in there. So now I get the first column extracted from the data. TAC F2 is going to give me the second column. And if I want more than one, I give a listing separated by commas. So 1 and 2 is going to extract the first and second column. I can also change the order here if I want. But it doesn't do anything. What did that do? First, last. Oh, it doesn't reorder them. It just takes them as the list of column numbers that you want to pull out. So for example, I could sort them based on age. 1, 2, 3, 4. And then let's say that I just wanted to grab the first and the last name. So I'd run that through cut. I need to give the TACD option because these are space separated. And then I'm going to tell it to just extract the first and the second columns. So now here's a list of first and last names, but they're sorted on age. So I was able to sort it first, then run that through and extract the columns that I wanted. And I mean, there's of course lots of computer science type of examples that we could do with this. This would be sort of database manipulation. You've got, some database type of information in a text file. But what we're really going to want to do is, I've got a file that's got data from an experiment. How can I write tools that will process that data from the experiment to automate a lot of the work that I might have to do? Like, we're typically going to have to calculate, if I take 10 measurements, I'm going to have to calculate the average of those 10 measurements. And then I'm going to have to calculate the standard deviation for those 10 measurements, and then calculate the standard error so that I can give a number with an uncertainty quantified. All of my cut examples, let's see here. I need to add this TACD option so that it will actually cut up the columns based on the space separated. So here I'm going to cut out the fourth column. Columns are separated by a space. I'm going to print everything that does not match age, and then I'm going to sort that. So what I'm doing is extracting the column that contains the ages, removing the header, which is not a number, and then I'm sorting that. And so this is just a list of the ages now sorted. Let's say I wanted to know what are the oldest, what is the oldest person in the class? Not necessarily their name, but I just want to get the age of the oldest person in the class. This pipeline, once I fix the TACD, should do that. So the first thing I do is I extract the age column. I run that through grep to remove the header. So I get rid of the word age. I run that through sort. I tell it to sort numerically and also do a reverse sort. So it's going to put the oldest age on top, the youngest on bottom. And then I run that through head with the tack in one option to say, just print out the top line. So this is a way for you to get minimum and maximum numbers out of a list of numbers. If you've got a bunch of, if you've got maybe a file that contains measurements, so they're randomly distributed, you want to know what the min, the max is, sort it, and then run it through head or tail. So now I get the age of the oldest person in the class. I'm basically going to do the same thing, but I'm going to get the age of the youngest person. The only thing I need to do, well, there's more than one way I could do this. Right? If I run tail instead of head, then that'll work. I do need to put this in here. Oh, I need to tell it to separate them by spaces. So tail gives me the youngest. The other thing I could do is I could use head, but not reverse the sort so that the youngest is now on top, right? Either one of those are going to give me the exact same result. I get 29 in both cases. All right, so this sequence command, if you just run sequence without any arguments, it tells you that it's missing an operand. But if you give it a number, it just prints out 1 through whatever that number is. And sometimes that is like something that you need at the beginning of a pipeline. Like let's say you were gonna do a calculation based on these numbers. Well, then you could get the number 1 through 100 generated before you start your calculation. In this case, let's say that I wanted to create the same database, like the same file, but I wanted to put line numbers on there. So I knew what the original line number was when I run these through a pipeline. So I'm gonna run the sequence command. Let's look at how many lines are in the info.txt file. So word count counts the number of lines, words, and characters. It tells me that there's 12 lines. So if I run sequence with 12 as an argument, it's gonna give me 1 through 12. All right, so let's save that to a file. And now let's paste the sequence that we just generated with the info.txt. So what that's going to do is it's going to take those two files and it's going to put their output next to each other. And so I should see line numbers posted first. So I got line numbers on the very far left, and then I have the content of the info.txt file following that. Now, one thing that the paste command does, which is actually common with a lot of these commands, is that if you give it a file name that's just tac, so if you give tac as the file name, then it will take standard input and read it in place of that file name. So for example, if I didn't want to have to create this temporary file, what I could do is send the list of line numbers in through standard input and then change that temp.txt to refer to standard input. So that would look like this, sequence 12. So now the paste command has got standard input coming in. Delete this, right? Here it just prints out the info.txt lines. But if I say that I have input coming in through standard input, which I tell it by putting a tag there, then it will read from standard input and read from that file and combine those. And if I change the order, I can get the line numbers posted after the info.txt file. Yes, Todd?
So you do the same thing with command substitution. So paste the sequence of 12 and then info.txt.
Oh, so you're saying, could I do paste like this? No. Because the sequence of 12 is going to expand into 1 through 12 on the command line, which then should refer to files that you want to paste together. So the arguments are the file names, and then the input is coming from standard input, and those two are separate from each other. So here I'm just going to put the line number in with the text. Then I'm going to sort it based on column 4. So then I'll have the original numerical or the original sorting maintained on the left here. Right? So you can see how this was originally line number 10, originally line number 12. You can see how the sorting has changed. So the BC calculator, or the, I don't know if it's called, I don't think it's bash calculator. BC is just a very simple command line calculator. If you just need to do some quick calculations, it's fine. Actually, what it's most useful for is if you have a script that needs to do some calculations, bash is not very good at doing very complicated calculations, but you can send the BC command the stuff that you want to calculate and use that in your script instead of trying to use bash for it. So for example, BC, if you type BC with no arguments, it opens up essentially a prompt and it starts reading input from the user. 3 plus 5 is 8. 10 divided by 2 is 5. 10 divided by 3 is 3, of course. Here's that integer division that's coming in. If I divide 1 by 3, I get 0. That's usually not what I want. To exit the BC command, you need to type Control D. That stands for end of file. That will tell it to quit reading input. I can't fix this integer arithmetic even if I put a period after 1, which we did in GNU plot. It still only does integer arithmetic. And so the way that I fix that is I give the BC command an option, and if I look at the available options, the one that I want is this mathlib, which is TACL, and that, it doesn't give you any indication that it'll do regular floating point arithmetic now, but it says use predefined math routines. That's the one that we want. So if I run, not GC, BC. If I run BC with the TACL option, now I do 1 divided by 3 and I get 0.333 like I would expect.
You also type quit to get out of it.
You can type quits to get out? Okay, so quit will also work.
So I tried to type exit and it's like you need to type quit to quit. I was like, why won't exit just work then?
So the TAC D or the Control D is a special character that doesn't print, but it has a special meaning. It means end of file. And that is actually how the pipelines work. So how does the sort command know when to quit reading for input? Why doesn't it read in the lines that you give it and then wait for you to enter more lines? Well, that's because after the last line of input is passed to the sort command, a Control D character is passed, and so it quits reading. And then it takes its output and it sends it to the next thing in line. So that's the same thing that happens with pipelines if you use Control D. So most commands that take a read input from the user, so you type in commands from the command line, will quit when you give them the Control D option or Control D character. So for example, if I just wanted to run BC without opening it up, I could echo whatever it is that I would type in to the BC command prompt. I give it the TACL option so that it'll use these standard predefined math routines, and then it'll output the result of that calculation. So 4 plus 5 is 9. The way that this becomes useful in a bash script is that I can use variables to construct the expression that I want it to evaluate. So let's say I set a variable A equal to 4. I set another variable B equal to 4. If I echo A divided by B, I get 4 over 4. If I send that to the BC program, it will calculate that expression for me and print it out to the standard output.
So would this be how that you could pass a variable name into a new command? Like say you wanted to run GNU plot using like a single command that takes in a file name and then runs GNU plot on it with specific commands.
Yep. You could get it, you could pass in, like if you were using a bash script, you could pass in the file name through positional parameter, and then you could create the string that you wanted to control GNU plot based on that variable, and it would expand to the positional parameter. Yep. So in the example that Tyler was talking about, I could run, if I had a script that would search for the error commands, I could use command substitution to set a variable equal to the total number of files that matched that pattern, then run those through the second one that matched for the what was it, the bad data error, set another variable equal to that, and then use the BC command to calculate that ratio. All right, I'm in the top directory of the sandbox again, and I'm going to go into the data directory. And if I look at the data directory, I've got a couple of files in, or a couple of directories in here. One's projectile motion, one's for quantum mechanics. So I'm going to go into the projectile motion directory. Now, you guys, do you remember in Phys 1, Dorn, have you guys done the projectile motion lab where you shoot the spring cannon and you have to measure the range, right? So when you wrote down the ranges, if you wrote them down in centimeters, you might have got a set of data that looked something like this, other than all of these extra digits that you wouldn't have written down, right? So 151, 154, 154. Let's say you wanted to know what the shortest range in the group was. Well, you just sort your ranges and run that through head with the TAC-N1 option. You get the shortest range. 141 centimeters was the shortest range that was measured. You want the longest range, you do the same thing, you run it through tail. So you've got a range of ranges, 141 to 159. Yours was actually probably much smaller. Those things are usually pretty tight. It's like plus or minus a centimeter when you do it. All right, so for a second, let me go up into the main directory and go into the scripts directory. I've put some scripts in here that do some additional processing. So I've got a couple of scripts in here, one that plots data and one that is called average, or AVG, that calculates an average of numbers. If you look at this average script, it's just a very short Python script. And all I'm doing here is reading lines from standard input and calculating the average. So it's set the sum equal to 0, set the number of data points that I've collected equal to 0. And then this line right here says loop through all of the input that gets sent in to standard input. And I just increase the sum. So sum is equal to what it was last time plus whatever number gets sent in. And then I do the same thing for the number, and then I just divide that sum by the number. So I'm basically just calculating an average here. Now, since this is not a command that's in like the bin directory or a special system command, I got to use // to run it. If I run this command without any arguments, it starts reading from standard input. Let's give it some numbers to read. 1, 2, 3, 4. Now give it a Control-D so that it'll quit reading input. And where's it at? Quit reading input. Did that work?
Yeah.
What did it print out?
2.5.
2.5?
What the hell, dude?
I'm gonna go back into my sandbox directory. Scripts.
Yeah, Control-D twice.
Average command 1, 2, 3, 4. Control-D, Control-D twice. Gives me 2.5.
Oh, jeez.
So now let me go back into the data directory, projectile motion. And let's say that I'm looking at all of these, the files in this ranges, or the points in this ranges.txt, and I want to know what the average is. Well, let's just cat that file and then pipe it to that script. I need to give the relative path name to that script though. So that script is up 2 directories in the scripts directory named average. So 150.6 is the average. So what's really nice is I don't have to write a script that is going to know how to read stuff from a file or handle all possible cases where, well, does the user want to give the input into a file or do they want to send it through standard input? Just read from standard input, do your calculation, print the standard output. Now, whatever your tool is can go into a pipeline. All right, that we better stop there.